The topic is Cloud Computing Models and Vulnerabilities, Raining on the Trendy New Parade. The speakers are Alex Stamos, Nathan Wilcox, and Andrew Beckerer.
Hey, thanks everybody for coming. I know it's 10 a.m. is 5 a.m. subjective time on the second day of Black Hat, so it's nice for people to show up. My name's Alex Stamos. This is Nathan Wilcox and Andrew Beckerer, and we're going to talk about cloud computing. Got a lot of content, so we're going to try to go pretty quickly, and then hopefully have a little time at the end for questions. So we're talking a little bit about cloud computing in general, and then the talk's broken into 3 parts for 3 different audiences, because we like to be everything for all people. The first part, software as a service, we're really going to talk about the CSO crowd kind of concerns about audit and legal issues and forensic issues and incident response in the software as a service environment, which thanks to Twitter is a much more relevant thing for us to talk about this week. The second part will be Nathan talking about platform as a service, which is going to be a focus on if you're an application developer or a security expert looking at applications developed in the cloud and platform as a service platforms, the things you need to think about security-wise and the mistakes you can easily make that are different than writing web apps locally. And then Andrew's going to talk about infrastructure as a service and some interesting low-level issues that come up specifically with the Linux kernel when you start to virtualize everything and then make everybody's virtual machines public. So we were very fortunate to make Jeremiah Grossman's list of talks that he was going to go to in his blog, and which is a big personal honor of ours. And one of his commenters, I guess talking about our talk, asked, am I the only one who has the urge to punch myself in the neck whenever I hear about the cloud? And I wanted to say, is Arshawn here? Did he actually come to Black Hat? But he's not going to be here because he's not punching himself right now. The answer is yes. Arshawn, you are not the only one who has this urge whenever you hear the term cloud computing. It's because the term cloud computing is useless at this point. It's really a term that's meant to separate either CIOs or venture capitalists with their wallets. Has very little to do with actual technology or the way a technology is deployed or even used. It does not apply to IT virtualization, enterprise virtualization, going and taking 500 Windows machines, putting them on VMware ESX. There's some good things and bad things about that. That is not cloud computing. It isn't remote backup. Just because it's a remote backup service does not make that cloud computing. Most of the things that have cloud computing attached are not cloud computing. And this gets really irritating. Has anybody here ever actually gone to a cloud computing conference? Right? It's horrible, like the number of metaphors and similes and stupid little terms like cumulousify and cloudify and all the words people have created around cloud computing. It's way more of a marketing term now. And as a result, I think for a talk like this, it's important for us to really define what we're talking about so we can talk about the real security impacts. Real cloud computing generally means you have lots of general purpose hosts with non-specialized hardware. This means that you have lots of hosts and very few of them, they don't have directly attached terabytes of storage because they're a database server. Most of them don't have massive amounts of memory because they're doing something special. General purpose hosts that can handle lots of different workloads. Centralized management of those hosts is very important. Distributed data storage, for the most part, cloud computing infrastructures do not use a single SAN or NAS array in one part of a building. You're talking about locally attached storage on thousands of commodity lintel boxes, and then using software to tile those machines together in something that's more or less reliable and more or less performant. The ability to move code from system to system is an extremely important part of cloud computing, and the place where most people fall apart when they describe something as cloud computing. Just like building a Windows virtual machine with Exchange on it and then moving that Exchange VM from one machine to another is not cloud computing, because you're not actively deploying new software and having it reconfigure itself based upon the elasticity of the computing resources it needs, right? If you have a Java servlet that you can push a button and it goes to 1,000 machines and is able to locally find its data store through a distributed data service, it automatically gets its load balancer set up, that's cloud computing, right? The software has to understand that there's an elastic and flexible services underlying it, not just being moved from machines using virtualization. That doesn't count. Low-touch provisioning is very important, and soft failover and redundancy. And this is the reason that a lot of cloud computing stuff is going to go by the wayside, why I think the bubble is going to be popped, is people are going to start to realize that cloud computing does not give you the kind of hard transaction security and transaction atomicity that people demand for certain workloads. the idea of cloud computing is to do things on web scale, right? It's folks like Google and Yahoo and Facebook running tens or hundreds of thousands of commodity machines, but those folks don't really care on a per transaction basis about being safe. If you connect to Google Maps and you do a query, and in the middle of that query, the front-end server you're talking to has a power failure, you will lose your HTTP connection. Your transaction will not go through the back end, whatever it was. You will have to hit reload and do it again, which is not a big deal if you're using Google Maps. If you're doing a atomic financial transaction between two big banks, obviously that's not the kind of thing you can have. And so I think people don't really understand that part, that you can't really rely on cloud computing to give you the safe computing base to do a lot of dangerous things, and so that's where a lot of people that want to do it internally are going to fail. A basic thumb rule is, if you're not rewriting your software, it's not cloud computing. If you can use off-the-shelf software, you're not really doing cloud computing. As a result of the term cloud computing being so misused, if you want to make any kind of technological or policy assessments of the security of a cloud computing deployment, you have to think about the specific model, and we'll talk about 3 models: platform, software, and infrastructure as a service, and certainly the specific implementation. If anybody talks about cloud computing security in general, and this includes us, they're trying to tell you something, right? Nobody can say something like cloud computing security is bad, right? Or the cloud is secure. That doesn't mean anything. If somebody says that, you instantly need to mark a little bit in your brain that this person doesn't know what they're talking about, right? And use that for everything else they say, to be a little bit careful about their judgments. Okay, so we're going to talk about software as a service. In a software as a service model, this is kind of a generic IT software stack. In the software as a service model, the entire stack is outsourced. Everything down from the air conditioning units, cooling down the computers, all the way to the front-end web software and JavaScript software belongs to somebody else, is somebody else's responsibility. This can be actually a good thing. And one of the big positives about cloud computing is the people that provide cloud computing services are generally smarter than you. The big providers, Google has something like 70-something application security experts. Microsoft has something in the low hundreds. Even Salesforce, which doesn't have a ton of products, they have about a dozen application security experts now. The median Fortune 1000 company has 0, right, application security experts. They have network security people, they have firewall guys, they have good sysadmins, maybe some very good internal pen testers, very few people that really understand software security. And so outsourcing your stack to people that really care about security can give you a big benefit, right? Unfortunately, there are also some downsides. And obviously, the one thing in software as a service that isn't outsourced is your data, right? That's your data, that's your responsibility as an IT guy sitting in their storage array. And you can't really outsource the responsibility for that. So the recent Twitter incident, who heard about the Twitter break, TechCrunch? Yeah, is Michael Arrington here at Black Hat? Yeah, it'd be interesting to have a discussion about the ethics of that whole thing. So for those of you who don't know, a couple weeks ago, an attacker, some guy in France it looks like, was able to download all of Twitter's sensitive internal documents and then sent them to a bunch of journalists. And these documents included things like their financial projections, which are a good laugh if you want, Twitter's gonna make $10 billion in 2011, no problem. Their term sheets of offers to buy their stock from Google and Microsoft, obviously a little bit sensitive. The list of executives from other companies that have interviewed for jobs at Twitter. And a lot of the internal deliberations about how they're going to monetize their service. Obviously, this is pretty sensitive and could actually affect the future of the company because it does make it difficult for them to make deals when this kind of information is public. Twitter was not a security breach. There was no, all of their documents were stored at Google Documents using something called Google Apps for your domain, where Google provides you with outsourced spreadsheets and a Word copy and a thing called Presently, which is like PowerPoint. And it's tied into a Gmail account, and you have integrated calendaring and all that kind of fun stuff. Nobody broke into Google. Nobody had a software bug in Google. It wasn't even a software bug in Google to phish somebody. It wasn't a cross-site scripting attack or anything like that. A high-ranking Twitter employee was using the same password on multiple sites. And an anonymous attacker who knew none of these people were able to figure out the email addresses of a bunch of important Twitter people, and then tested those email addresses to see at a bunch of different popular sites, probably like social networks and such, whether or not they were a member, and finally found a site that person was a member of that had a pretty insecure password recovery policy. That password recovery policy, you could click a button and get your password sent to an email address. It turns out that email address was no longer registered at Hotmail, so the attacker was able to register a Hotmail address and click a button and get their password, log into Google Apps, and pull down all their documents. no security flaw, but does reinforce a very important point, which is no matter how low an opinion you have of your users, they will figure out a way to disappoint you, right? And if you guys will help me in kind of my coup de grace of self-aggrandizement and ego, I'm going to try to call this Stamos' law. So if you guys can try to use it in any case possible, it's either that or Stamos' corollary to Murphy's law, right? This is true. Computer users are dumb, right? The median age, the median intelligence of the normal user on the internet is going down, and any people who run an organization more than 20 or 30 people has very little control over the technological sophistication of your least sophisticated user, right? And that's exactly what the Twitter incident. Twitter is supposed to have all these smart employees that are the best and the brightest. They certainly have high hopes for themselves, and they made very, very elementary mistakes. It brings up the question, what do we lose going to like a Google Documents? What kind of traditional IT controls do we lose in software as a service? Physical and logical network barriers. This is something people say all the time. Oh, everything's open and network barriers can't stop me, and firewalls are have no control over me. But there is some certain power in if Twitter in this situation was using SharePoint, God forbid, and it was on the inside of their network, being able to have your password guessed remotely possibly would have taken a lot more work for the person to be able to download all their documents. Endpoint restrictions and management. A lot of people have spent a lot of money controlling what machines connect to their network and how those machines are managed. The ability to do noun and password authentication is not supported by default in most of the software service vendors, although there is a lot of movement here, and we'll talk about that. Fine-grained credential quality controls. For the most part, if you use software as a service, you have to accept the little JavaScript bar that grows when somebody types their password in. And those standards are generally not, those are consumer level standards, right? Like if Google is able to get somebody to open up a Gmail address and have a number in it, they're lucky in their password to not use the word password or a last name. You generally want to have a higher level of password quality in an enterprise situation. The password reset process. Nobody's ever come up with a good way to reset your password with an organization that you only have an online presence with, right? You can do the email, which email can be stolen and spoofable. You can do DNS attacks against it or break into somebody's mail exchanger. You can do SMS messages, which if you think the SMS messages are secure, you should go down the hall to Zane Lackey's talk right now. Don't, no, I'm in big competition with Zane to see who can fill the room better. You can have ask you questions that only 700 people know, like what high school did you go to? Where did you go on honeymoon? All this kind of stuff that's on your Facebook page. There's no good way to do password reset. As a result, organizations that have physical plant are able to do things like if bank wants you to reset a password, you can actually go into a teller and say, I want to reset a password, or talk to somebody on the phone. That's much more difficult for software as a service. Real-time anomaly detection, because you don't have a real-time stream of activity. You can't detect, oh boy, somebody from France is reading all our documents. Maybe that's strange, right? I know a lot of people in here think that some of these things are snake oil, and they are. I'll give you a hint. Half the stuff that's being sold on the floor down there will not improve the security of your enterprise. But put together, putting these controls in place in a major enterprise does make the job of an attacker harder. Hackers are not unicorns, right? They can't magically walk through walls and magically, get around protections. And I think our group kind of suffers from a lot of security nihilism, where it's like, oh, that protection isn't perfect, so it's useless. And that's not true, right? Making something a little bit harder has a value. And in this situation, there was no barriers in place. And so a guy that had pretty much no technical skills was able to steal all these people's information. If you put up a little bit of barriers, it can be harder. And so we're going to talk about how to put some of those barriers back up. So for example, of an account quality issue, some might question whether or not the same password quality and password reset processes that you use for a bookstore is appropriate for the same password that owns your entire data center, right? Right here, like you have no choice but with Amazon when you sign up for an Amazon account, which works with EC2 or allows you to buy books at a very reasonable rate. And you have no choice but to set a password reset email account, right? That they'll send a link to that you can use to reset the password. You have no other options like SMS or out-of-band communication with them to reset it. And so that means if you're using EC2, the security of your entire data center is only as secure as your mail exchanger. Right? If somebody can break into your mail exchanger for 5 minutes, then during those 5 minutes, they can take control of your entire enterprise. That I don't think is the thing that most people want to sign up for, and so that's the kind of thing we have to think about when we make these decisions. One of the big problems with software as a service is the audit and incident response capability is not appropriate at this point. Twitter, I'm sure because things were so important and it was in the front page news, was able to call up Google and get Google security help looking at raw logs and stuff. But from the information that was available just through Google Documents, it would have been difficult to impossible even to figure out who the compromised account was once they knew there was a compromised account. The kind of data you need, if you're having a very, very bad day as an IT guy, the kind of data you need is who is logged in, when, from what IP address did they do so, what administrative actions were taken, especially if somebody's able to compromise an administrative account, you're going to want to roll back all the things they did, like add new accounts and change passwords and such. And what documents or data were accessed during the period of time I had a breach. A quick comparison, Google Apps and Microsoft Office Live are both started as consumer-grade software as a service that are now drifting towards enterprise-grade. It's perhaps unfair to judge Microsoft on this because they're not even there yet. They're really still only providing a consumer-grade service. They don't have kind of an understanding of enterprises. They don't have any kind of integration with enterprise login and such. Google, I believe, is there. Salesforce, on the other hand, started on the enterprise side and so had a very different set of security requirements from the get-go. I'm not going to read this chart. You guys can all do that real quickly. Some obvious things to note is login and admin events are not available from Microsoft or Google in a software as a service system. Salesforce puts that all in one place. And none of these guys can you by default get through either a web service API or a website document read or data read records, which is obviously very important in case of a breach. So for example, this is the Google audit logs that you can provide. An individual user on Gmail can click the button at the bottom of their page and see the last 5 logins they made, what time it was, although they don't give you absolute time, it's relative to the current clock, and what IP address it came from. The admins from the admin page can only see the last login time for a user, so they can't even see all of the login records that happened. I have an official response from a gentleman sitting in the front row. Do you want to be identified, gentlemen? No? Okay. His name is not Matt Moore at google.com. Google said that more of this information is available from their web service API than from the web interface, which is a especially googly answer that it's like, oh yeah, just write your own custom Python security suite so you can monitor this stuff. But it turns out the stuff I'm really looking for, while you can get access control lists and stuff from the doc list API, you can't get actual access controls. On the other hand, Salesforce, if you look at their admin interface, not only tells you is this user at this time, they give you the source IP address, they give you where they logged in, as well as information from the user agent field, which is obviously easily fakeable, but in my history of looking at some of these breaches, you'd be shocked how many people still have Firefox 2 with Russian language set, right, on Linux. People are not too tricky about doing things like changing a user agent once they've breached a site. The other interesting thing you can see here is by default in a Salesforce organization, they do the same thing that big banks do, which is set some kind of persistent flash cookie or persistent cookie in your browser to identify your browser as authorized to talk to them. So if you go to Salesforce and just try a password out, they'll say, oh, you're not authorized, we're going to send you an email. So in that situation, if somebody has lost their password, if there has been a password guessing attempt, you have a little bit more protection that unless the attacker also has access to your email address, you might be in pretty good shape. There are some alternatives to try to return some control to yourself. So Google and Salesforce and some other folks all offer single sign-on integration using SAML. So in those situations, instead of using, if you go to the Google Docs page, instead of them giving you the standard Google login, they'll redirect you to a page owned by your company. And that page will say, enter your credentials, yada, yada. And then it will do a redirect with a SAML assertion to Google saying, allow this person to log in. So doesn't that get rid of a lot of the benefits of cloud computing? And the answer is yes. The most important benefit it gets rid of is you've now created something that your enterprise controls that's in the critical path, right? That cloud computing is all about the IT department getting out of their SLAs and not being responsible to anybody, right? Oh, it's broken, it's Salesforce's fault, it's not my fault. So it does return some of that responsibility back to your IT department. But some of the things you can do is you can do an alternative credential scheme, like client-side certificates, like RSA tokens. You can have complete control of your password policies and your password reset policies. You can do anomaly detection, because now you have a real-time stream of this person's logging in from this IP address at this time. And if you want to get really hardcore, you can return some of the network protections back into software as a service by taking this portal and putting it behind your VPN, So somebody has to be either physically connected to your network or on their VPN with all of your endpoint management stuff to get to the portal to get the SAML token to go back to Google. So while all of your data will be going over the internet, hopefully encrypted if you click the button that says SSL only, the actual authentication will happen on your internal network, and you've kind of gone to the ability to not have to host any of these documents to have the level of control you had back when all this stuff was internally in SharePoint. So our recommendations on software as a service right now, strong policies and user education are absolutely key. Obviously, it's very difficult to teach all of the non-technical people in your company how to prevent getting phished. But the fact is, with software as a service, phishing attacks are going to become something that's not just a personal issue, but an enterprise-wide issue. And it's going to be very, very important to educate folks so they don't get stuck on that stuff. Use your offsite single sign-on if available. And think about, OK, what am I going to do if I have a really bad day? What can I do right now with my internal systems? And try to map that out to the cloud. So let's talk about some of the legal and regulatory issues with cloud computing. And these issues are actually not just for software as a service. They're for software platform infrastructure, basically any of these services that you can outsource to. To compile some of this information, I talked to Joe Gratz, who's a fantastic IP lawyer at Dury Tangri. I think they need more names in that title, right? Like, we totally should have named our company after everybody who works there instead of just ISEC partners. That would have been so much more useful. And then Jennifer Granick and Kurt Opsahl from the EFF. OK, liability concerns. Turns out that all of these big companies have very, very active and well-trained legal departments. And as a result, the agreements that you agree to when you sign up for any of these services basically promise you absolutely nothing. If somebody breaks in because of their mistake, doesn't get you anything. If you have a data loss because they have a data center burnt down, they'll do nothing for you. If there's a massive disaster, or if the company goes bankrupt, or they decide, hey, this isn't a profitable line of business anymore, wipe it out, you're gone, your data's gone. Obviously not a very happy situation. It's unlikely that you're ever going to get these big companies to sign up for anything that reeks of financial liability. But certainly, it would be nice if in some of these legal agreements they made you promises to at least try, right? No way Amazon's ever going to say, we are totally responsible for all security faults, but it would be nice if they had language in there that if there is a security breach, we're going to give you a hand up. And this seems to be where there's a disconnect between the cold, harsh, bloodless world of the lawyers and the nice, real security, warm human beings that you can talk to if you know people in these organizations. Where those nice, warm security human beings are like, yeah, totally, we'll help you out. Don't worry about it. Of course, I've bought some of those guys beers personally, so that's a difficult thing to extend to every single company that might be using services. And in fact, is going to become, if some of these services become incredibly popular, there's almost no way that they can provision out security services to support everybody properly. So this is the kind of thing you really want to think about when you sign these agreements. Self-testing is an interesting issue in a software as a service or platform as a service environment, or infrastructure, excuse me. Specifically, the EULAs of all these companies say, hey, don't do anything bad to us, which is pretty much normal. That is in direct conflict with a lot of people's regulatory requirements and PCI and stuff like that. Again, if you talk to these folks, like Amazon says, if you have the permission of somebody, you can pen test EC2 instances all day, all night, right, from the network stack down. And Salesforce and Google actually have public responsible disclosure policies that they put out. And they've also said that people are allowed to do application penetration testing against apps stored in their environment. The lawyers we talked to, looking at the legal agreement, said, hey, that's a great thing for somebody to tell you, but the recommendation to us, and therefore to all the security professionals out here, is if you are asked to attack or pen test software in the cloud, they recommend at least having email permission from somebody at that company saying it's okay. Because certainly, by the letter of the law, the physical ownership of those machines is very important, as we'll see in another second, in other issues. And no matter what the people at different layers say, it's at that bottom layer that they can call the cops on you, or that they can sue you. And so it's very important to get agreement from that bottom level, at least in email, if not in a contract. Search and seizure. So this is where things get really scary in the cloud computing world. A big question is, if I use cloud computing services to store my data versus either if I'm an individual in my home or if I'm in a business in a facility I control, does it decrease my protection for that data being taken by either law enforcement or civil plaintiffs? And there's two totally different paths here. For law enforcement, you talk about things like warrants, and law enforcement can issue subpoenas. Civil plaintiffs, it's all subpoenas through civil action. The answer that we found is yes, at least at the current state of the law and the current interpretation of the Obama Department of Justice, which has not changed the interpretation of the Bush Department of Justice. You have massively less protections using cloud computing than if you use your own computing resources. This is the Fourth Amendment to the United States Constitution, and unfortunately it's gotten a little faded in the last couple of years, and it's difficult to read. But the important letters here for this case is that you are secure in your person's, house's, papers, and effects. And the government says that your person's, house's, papers, and effects does not include your data if it's on a hard drive in a data center that's owned by Google or Microsoft or Salesforce. The physical location of your data is important, and this is where it gets kind of stupid, right? But if you have a hard drive and it's in your house, the Fourth Amendment provides you with protection. If your data is at Google, you have no constitutional protection for that data, absolutely none. Now, below constitutional protections, there's statutory protections, which is the federal government making laws about what can happen, what can't happen, and then state governments making laws about what law enforcement can and can't do in their own jurisdictions. There are a couple of laws here. It's very, very complicated. It all comes down to most of them only protect communications because they were specifically thinking about things like voicemail when you're talking about stored data in places. So a big question is, if I type data into a Google spreadsheet, or if I upload data into a Salesforce contact, is that communications? I mean, I had to communicate it to Google, right? It went over the internet. But the big question is it treated as communications by the government? And the answer right now is no. The Department of Justice will try to subpoena you without a warrant because they feel they can. So what specifically do you lose? If you don't have Fourth Amendment protections, you don't have the protections of a warrant. A warrant has to be signed by a federal magistrate, and the law enforcement officers talking to the magistrate have to have evidence that they meet the probable cause standard. There's a bunch of rules about being notified about warrants, and in most cases, because you don't, in cloud computing environments, you will not have the ability to fight the seizure before it happens. You can fight it being used in an action against you later, but unlike if they actually kick down your door, they don't kick down the doors of big corporations, they serve them with process, and usually their lawyers have some period of time in which they can go and try to fight it and not have it happen. You have no control over that if they issue a subpoena to your cloud provider. In fact, the real problem here is that you might not even know if your data gets taken. There's no legal requirement for somebody holding onto your data to notify you if somebody's come and taken it under color of law. In fact, they can even be gagged from doing so. There are mechanisms by which you can tell Salesforce, give me your data, and then, oh, by the way, you can't tell the people that we took their data, whose data we took. So, people might be thinking, oh, well, I don't do anything illegal, I don't care. But for companies that are building on these platforms, you're going to care, right? Like if you wanted to build a social network, and instead of buying a lot of machines, build your social network on Amazon EC2, then if you have people on your social network doing bad things like kiddie porn or passing around copyrighted material, you want to be the person responsible for that, right? You want it to be your legal people that deal with that. And in fact, if the Department of Justice is like, I don't like these people, they can just go to Amazon directly and get that data. And then the other issue is that this is where it gets all gray, there are things called administrative subpoenas, which are subpoenas given out by like the SEC and other organizations. So any big company at any time can get investigated for doing some bad stuff with their money. So if your information about paying your taxes is in the cloud, you're in much worse shape than if you have it locally. So here's a quote actually from the EFF. Now, this isn't how it should be. This isn't how they think it's supposed to be. This is just how the Department of Justice and judges have judged it so far. But there'll be a lot of, over the next 10 years, litigation over this kind of stuff. Their suggestion also is, if you really want to put data in the cloud, is encrypt it with either something that's in your head or something that's within your physical home. Because then to get that encryption key out of your head or out of your home, they have to have a much higher level of legal protection. Spoke to Google about this and got a typical, very short, succinct answer from one of their attorneys. It's nice, it's long and kind of wordy. It is kind of a nice sentiment, though. They basically say, we are committed to the security of our users, and so in every situation that we get served with this stuff, we will try to talk to the user. So Google is not responsible for the fact that national security letters exist, but it is nice from at least one provider to hear, in every situation, we will try to notify you if your data has been taken. Obviously, that doesn't, it's nice for them to say that. It would be great if this was actually in their EULAs, in their legally binding agreements. I'm guessing something they sent to me in an email that I put on a slide does not make it legally binding with all of you, but I'm not a lawyer, so. Anyway, Nathan's going to talk about platform as a service.
So, my mic's on? Good. Alex just talked about some operational and legal concerns with cloud computing, and next Andrew's going to explore some implementation issues. But in this part of the talk, I want to talk about design issues. And so my goal is to discuss how security works out of the box for applications developed on platforms as a service. And hopefully that will help developers know what to look for, reviewers know what to look for, and hopefully it'll help improve those platforms. So in this talk, we're moving down the stack, and now when we're talking about platforms as a service, what defines them is that they offer some kind of development framework upon which you can write your own applications. So that's why I'm focusing on a developer perspective. I'll be talking about these services, and as a disclaimer, we work with all of these companies, but not necessarily on their cloud platforms. So what I did is I looked at App Engine, Windows Azure, and Force.com, and I reviewed their web application frameworks, and I looked for well-known web security attack surfaces to understand how these platforms handle those attack surfaces out of the box and what challenges there might be for developers. So the questions I'm considering are pretty basic. They're not security research questions. We'll get to some of those. But these are just, is it secure out of the box? How easy is it for developers to do the right thing in terms of security? Or how easy is it for them to get it wrong? And how could the design be better so that developers can tend to write more secure applications without having to have special training? And the attack surfaces I looked at are really common, widespread: CSRF, XSS, and SQL injection. We all know about these. And even today, finally, general developers should be pretty aware of these. And the reason they're interesting is that general web application frameworks address these issues to some degree. So they each present a different challenge, as we'll see. So cross-site request forgery is subtle and often misunderstood. So sometimes in working with clients, I'll hear developers claim that a CSRF vulnerability isn't a problem because their application is only accessible behind a firewall or only accessible over SSL. And so that kind of exemplifies how it's easy to misunderstand this problem. But the good news is that frameworks can solve this problem almost transparently so that developers don't really need to understand anything special as long as they follow the framework's design. And the way frameworks do this is by tying form submissions to particular sessions so that attackers can't formulate a request and give it to a different session and have it execute successfully. Developers don't need to know much at all. They just need to remember not to modify state through GET requests, only POST requests, because that's where the mitigation operates. So if we look at Google App Engine and we Google for CSRF in their documentation, we don't find anything. Try various queries. That's a little distressing. If we look in discussion groups, it doesn't sound like people are asking, how do I enable CSRF protection? So the good news is that it's possible to implement CSRF protection if you switch to Django. I should point out that App Engine's default web framework is derived from Django, and so it shares a lot of functionality. But this is a prime example of how there's a difference now that developers may not be aware of. So Django can mitigate CSRF out of the box if you configure it correctly. If you want to use that protection on App Engine, you can switch to Django, and then you can enable Django to use that protection. So moving through these slides quickly, these are just from public documentation. Here's how you use Django, and here's how you enable it to protect against CSRF. When we look at Azure, we'll find that it also doesn't have any specific documentation on CSRF with respect to Azure, but there are MSDN docs on CSRF for ASP.NET, and the default framework in Azure is ASP.NET. So that's good news. There's training for developers. However, there's kind of a gotcha. There's been a somewhat confusing history with using view state to protect against CSRF, and there's been multiple developments. The current best practice is to do what you see here, and I have a reference at the bottom of where I found this code. So this ties something, a secret specific to the session, to the view state user key that's going to go into postbacks on the ASP.NET application, and that will prevent CSRF attacks. The trick is that the session has now changed once you move from a classic ASP.NET deployment onto Azure. And the reason is that multiple requests to your application on Azure might go to different VM instances. So there's no load balancing persistence or anything like that. And so you must ensure that the session state is managed in shared storage on Azure. And doing that is a new skill set that developers need to learn. So the developer SDK comes with some demos on how to do shared session state. And so the trick here is that developers need to tie together these two issues, the configuration issue for shared state and the best practice. And they might not make that leap, and they might end up with an unprotected application. When we look at force.com, we find that standard controls have CSRF protection by default. So that's pretty good. Developers don't need to learn how to configure anything. There's kind of a trade-off we'll see in that force.com is a completely new language and framework. So the trade-off is developers have to learn this new platform, and they can't take their existing knowledge from existing platforms. Their documentation points out correctly that if you write a custom handler, it's easy to accidentally bypass this protection without realizing it. And this example is from their documentation. And I just point out two issues here. This example relies on the ID, and it doesn't do CSRF protection. Therefore, the ID parameter is vulnerable. And the other arrow I have here is that the precondition at the very beginning of this method does not include CSRF protection, but a developer might assume one way or the other. So it's a good thing the documentation's there. So if we think about CSRF, what have we learned? There's been deviations from ancestor frameworks because the cloud computing vendors, platform vendors, want to use backwards compatibility to entice people to migrate easily to their system. But in deriving from these frameworks, there are differences, especially in configuration. And so that could lead to potential problems when developers already expect these mitigations to be in place. And when they move to a new platform, it looks the same, but this transparent thing is now missing. Force.com trades a better default at the cost of learning a new platform and language. And again, custom handlers tend to inadvertently disable protections, and this is common in many frameworks. Moving on to cross-site scripting, this is an interesting case to delve into. It's more complicated than CSRF. First, I want to point out that I focus on output encoding instead of input validation, although both are helpful. But with input validation, there can be problems validating all kinds of input. Some things are hard to parse and verify correctly, like poetry or Perl. So output encoding is necessary. You might use the same data in multiple contexts, such as HTML and SQL, and we'll have different output encoding rules, and therefore you need to do output encoding. XSS requires more developer awareness because the developer is writing a template, is using untrusted parameters from the outside, and so they have to know when to escape those parameters using output encoding. And they have to know the context they're escaping into, and this point is a little subtle, and many times developers and frameworks miss it. So when we think of platform as a service, it's not really fundamentally different than traditional web applications in this respect. And the reason is that the platforms as a service need to maintain compatibility with the web. They don't want to break that. It's a major selling point. So between the application logic all the way to the user through the web browser, we shouldn't expect many changes. If we look at App Engine, its mitigation technique is the same as Django. You can use filters on parameters in templates, and there's one called escape. And so that's what you should use to escape parameters. It escapes for the HTML body and HTML attribute contexts when it's not JavaScript. And here's an example. Here are the two contexts. Both the body, Santa is saying something, and there's a limerick and an attribute value. When we look at Azure, it's going to follow standard ASP.NET again, because that part of the stack or the framework hasn't changed between the migration from Classic to Cloud. And so the best practice is to use HTML encode or the inner text property for the same context as we saw with Google, and to use URL encode for URLs. This is an example of a different context that you should be aware of as a developer or a reviewer. And again, HTML encode and inner text are for the same context as the Django escape filter, and I'll show why that's important later. Here are two examples. I just want to point out that assigning to inner text is a little tricky for reviewers because it's a special case side effect in this assignment that depends on the name of the property. And so hopefully people who use the framework understand that side effect, but a code reviewer who's constantly learning new platforms and languages might be tripped up by that. So for that reason, I find the explicit function call, HTML encode, to be more explicit. Now, when we look at Force.com, we run into an interesting case because Force.com has broken from the past and is providing a new language and a new framework. And so that's refreshing sometimes for engineers to break from the past because you have the opportunity to do things right, because you're starting over. But if we look at Salesforce, we see they have two different front-end mechanisms, one called S-controls and one called Visualforce. And S-controls are starting to become deprecated. And so the takeaway lesson here is that even when you break from the past, you'll still end up with your own legacy. And so backwards compatibility is a problem that will always persist that we have to deal with. If we look at S-controls, they're largely based on JavaScript. So you must follow various JavaScript best practices in order to avoid injections. So don't use eval. Don't use implicit eval, such as the example here. And when you're using higher level DOM APIs to modify the page, use inner text, not inner HTML. And again, this is an example of how an implicit side effect of assignment has a difference with these two parameters, and that's tricky for reviewers. Finally, the server-side expansion, there is no real provision for HTML encoding in the server-side expansion. According to their documentation, they give this example, and this is pretty cumbersome. You have to manually do the substitution yourself, so the developer has to know really well what the output encoding rules are. The new system called Visualforce is a new template markup language, and so it's intriguing because any tag that begins with apex : will do output encoding correctly so that the developer doesn't have to explicitly encode parameters that are within the tags. And here are two examples. This is intriguing because it offers the potential for context-aware output encoding. And we'll talk about that soon. So cross-site scripting lessons. The platform as a service frameworks are pretty much status quo compared to classic frameworks, which we should expect. Force.com has a legacy despite a fresh start, as I described. And developers still need to understand output encoding contexts. And here's an example. So here's an example using App Engine or Django. And to a developer, it might look correct because escape is being used. But the context is rather confusing. It's JavaScript inside an HTML attribute inside HTML. So the escape rules used here are wrong for this context. So it's vulnerable to injection. Here's an example string. Even worse, if you look at the expansion, if you view source in a browser, this is what you see. And some people would think that that won't execute in JavaScript, but it will. So moving on to SQL injection. This requires developer awareness at every call site, just like cross-site scripting. But now we see a new challenge with for the cloud vendors and their designs. It's because they've changed the connection between application logic and the storage layer. And so for the most part, they don't use SQL, but Azure does. So since they're departing from the past, will they reinvent a broken wheel? I'm going to speed up a little bit so we can make sure to hear from Andrew. So Google App Engine uses something called GQL, which is a lot like SQL. It's like a subset of SQL. And therefore, the best practice is similar to SQL. You should use parameterized queries, as we see in this documentation that they provide, which is good, best practice. It's also possible to do queries explicitly and not use the separate query language. But because it's still a separate language and we're constructing strings and passing them to a library, it's still possible to do injections. So it is equivalent to the status quo for SQL. GQL is query only, so the impact of security vulnerabilities will be different than SQL. Azure is much like standard ASP.NET. In fact, it stands apart from the other services because it provides SQL as the storage layer, as one of the storage layers. And I want to point out something called LINQ, which is a technology which allows .NET languages to be extended to have query syntax as part of the language. And this is really intriguing because it might make the job of developers easier. The code might be easier to write. But more importantly, for security, it removes the attack surface of injections completely. So that's nice when you can kill two birds with one stone. When we look at Force.com, they have a new language called Apex that's based on Java, but it has queries built into the grammar, just like LINQ can provide for .NET. So it's the default in Force.com. You can still do old school dynamic SQL queries, and therefore there's still a problem. But since this is the default, it's a good thing, one less injection surface. So there are various approaches the platforms take to dealing with the query languages. And I find that the best is language integration because it eases developer complexity and it removes the attack surface. All of the frameworks still provide some backwards compatibility, so there's still the potential for vulnerability, but the goal here is to just make the default more secure. So here's a quick summary chart. For each attack surface, I just described succinctly how the different services deal with that attack surface. For App Engine and Azure, it takes two configuration steps that are documented in different places in order to enable CSRF protection. So that can be improved just by changing documentation. But I think they should follow the Force.com example to just enable CSRF protection by default. For XSS encoding, App Engine provides something that's pretty OK compared to standard web application frameworks. Use this filter. The developer still has to know that there's some context where the filter doesn't work, so avoid JavaScript, for example. ASP.NET is much the same, but I call it cumbersome here because there's two different approaches you can assign to this property, or you can call this function. Force.com has two different front ends, so it's dealing with the legacy, but the new approach is fairly lean because output encoding happens automatically. For SQL injection, or whatever is similar to SQL in App Engine and Azure, we see parameterized queries, and that's the status quo. That's the best practice for the rest of the industry. But Force.com is integrating language support, which removes an attack surface. So takeaways are make CSRF protection the standard by default, make output encoders more context-aware to ease the burden from developers, and integrating queries into the application language is attractive. It can remove the security vulnerability and make it easier for developers. So now we're going to talk about implementation issues and infrastructure.
All right, so I'm going to talk about infrastructure as a service today. And unfortunately, we've got 10 minutes left in the talk, and I've got 15 to 20 minutes of content. So much like in the movie, when the helicopter's running out of gas, they start chucking all the non-essential components out the door. I'm going to do the same. All right. First, I'll give you a quick introduction. What's infrastructure as a service? It is, we're going down the software stack. Now you own everything above the hypervisor. So you own the operating system and any applications that are on it. And I like to think of this much like C. You have the most control in the cloud universe, but you also have the largest gun with which to shoot off your foot. So I want to get something clear. Infrastructure as a service is not just virtualization. There are some really interesting properties. First of all, instances, virtual machines in cloud computing are much shorter lived. This is not an Exchange server in an enterprise data server in data center running on VMware that is going to run forever. These things might have a lifetime of minutes or hours or a day. Also, there's no persistent local storage oftentimes. The software is optimized for the cloud lifecycle. Just like Alex said, if you're not running software that's optimized for the cloud, taking advantage of certain features like elasticity, then you're not actually doing cloud computing. And you have helper services like S3, the cloud storage for Amazon, or Simple Query Service, a database-like service. All right, so we have some concerns that I'm not going to talk about. I'm not going to talk about hypervisor flaws. They're very important, active area of research. Not going to talk about it. Services, network segmentation, those types of things, as well as issues like flaws in the admin interfaces. Important stuff, not going to talk about it. Oh, networking. I already said I'm not going to talk about this. All right, so when operating systems were designed, when Linux was developed, there were certain expectations, certain assumptions. We thought that, well, first of all, what's unique about the operating system? There's a lot of unique or secret data in a particular configured running instance of an operating system. You have private keys, SSH, SSL. You have identifiers, your Windows machine, globally unique identifier. There are lots of important, things that are associated with a configured operating system. But what else do we assume? We assume we're running on real hardware. And of all the things I describe here about what does real hardware get you, the thing you need to take away is non-deterministic timings. If you have a hard disk in your system, you get non-deterministic timings from your I/O interrupts. That's going to be really important as we come up. So we're going to talk about random number generation. I'm going to try to breeze through this as quickly as possible. A quick background. So computers are deterministic. You can't get real random numbers from computers. Just accept it. But we do have pseudo-random number generators, and that's what we're going to talk about. Most random number generators are not cryptographically secure. Just a funny note, PHP has the empty-rand method. They describe it as a better way to generate random values, and that's better if you mean 4 times faster. It's not better, it means better for me if I want to compromise your PHP web app and you're using empty-rand to generate important tokens. So don't use it for poker, online poker. All right. So most modern operating systems have pseudo-random number generators in the kernel. There's an excellent paper by Gutterman and a couple other folks called Analysis of the Linux Random Number Generator. Google it. It's a great paper. The math is very accessible. So Linux gathers entropy in 3 ways. Input events, it's a headless server we're talking about, no input events. IRQ events, if you read the Gutterman paper, you'll find out IRQ events are not sufficient for gathering entropy. And finally, block devices. This is where you really get your entropy. Now, each I/O event that actually gets added to the entropy pool adds about a bit of data. Now, that sounds like a lot, right? Except most I/O events are actually going to get tossed out by the selection process in random.c. Disk numbers are predictable. We won't really talk about that. Here's something that's important, and this is kind of the meat of this talk, is that Xen implements I/O as a ring buffer. So you're now abstracted from your hardware, and your I/O interrupts are not behaving as they would on a physical system. You now have an underlying system. And this is an area of active research with myself and some other folks at ISEC Partners to determine the impact of this ring buffer implementation on pseudo-random number generation and specifically entropy gathering. So let's talk about the Linux, the life cycle. When a Linux system boots, they initialize the entropy pools with the contents of the real-time clock. Now, is that good practice? Maybe not. As we saw with Wagner and his work on Netscape and their pseudo-random number generator implementation, this proves to be a weakness. Real-time clocks, you can determine system time through a variety of means, and it may not be so strong. So we talked about collecting IRQ events and adding them to disk, but in virtualization, your IRQs don't behave the same as they do on real hardware. There's less jitter. That's important because the majority of your entropy is located in the low order bits of the timing of the IRQ events. This is really important. Okay, so normally on a Linux system, you seed your entropy pools. When you shut a system down, you save content from devrand or dev-urandom into a file, and then when you reboot, your init scripts put that data through the mixing functions back into the pools. In this way, you're saving entropy from your last run. So the state of your pool will be unpredictable. If your Linux distribution is not doing this, then that's a bug. And it's a bug that's been filed with Linux distros in the past and it's been fixed. On AMIs, the first time you run an Amazon machine image or any saved Xen, DOM-U, or untrusted host, that random seed is going to be static. It's bundled with the image. So, that kind of defeats the whole point of saving off this entropy and putting it back in the pool if this AMI is public and available to anyone on the internet, and I can extract that random seed. So once this process is done, we start doing important cryptographic operations. We start generating our SSHD host keys. We do that 44 seconds after boot. How much entropy are we gathering in 44 seconds, and what is the quality of that entropy? So we'll talk about, how would I exploit this? What is the attack lifecycle? Well, first of all, there's a system I want to compromise. I start to profile it. I look at HTTP headers. I discover this is Ubuntu Linux running a specific version of Apache and a specific version of PHP, and I know what its IP address is, and I determine that this is running on EC2, and then I start looking through the EC2 application catalog, and I determine that it's a specific AMI. I go get that AMI. Using S3, I pull it down, and then I extract the random seed from that AMI. So my next step is I rebundle an AMI, and I use an instrumented kernel module. Why do I want an instrumented kernel module? What I want to do is I want to build a model of that AMI. I'm going to put that AMI back up into EC2, hopefully in the same availability zone. Maybe I even make it on the same machine. I start to gather IRQ timings, right? I'm making a model. I have a block-for-block copy of what they're running, and I am going to make the best model I can of how entropy is being added to their random number generation pools. So now I use a pseudo-random number generator simulator. The Gunnerman group did this. And I input my estimated real-time clock value that the kernel initialized. Now this is a problem, right? I have to know when the system was started, but there are ways of dealing with that. I enter the most likely IRQ disk deltas, right? So I can find out at 44 seconds after boot, what would dev-random or dev-urandom give me. Then I simulate the SSH keygen and I test the fingerprint. Here is an area where we're also doing some research and trying to determine how can we speed up this test. Finally, if that fails, we just do it again. We're going to do this as many times as we can on our PS3 cluster while we're not generating MD5 collisions. All right. So, is this a practical attack? Maybe, maybe not. I need the birthday of the system. If SSH is not enabled, this isn't an attack. And this would definitely be better if we can figure out how to optimize the testing process. But it's dangerous and it should be fixed. And one way we can fix it is through a custom Xen device driver. With that custom device driver, we drill through the hypervisor, provide entropy up through the system, and people are calling for this anyway to improve the performance of random number generation. Also, we could bundle a custom random.seed, so that's not the same every time. And finally, you can just wait a couple minutes to generate your SSHD keys or regenerate them.
So quickly, some conclusions. When you move to software as a service, you take away a lot of the traditional IT controls that people have relied on in the past. It's very, very important to think about what those controls were and what assumptions you had and see if you can map them into the new world. Incident response in the cloud is extremely difficult. If I was in charge of security at a company that was moving into a cloud service, my #1 concern would be, what am I going to do on the inevitable day when something bad happens, either a rogue internal employee or an external breach? There are very, very important legal stumbling blocks to doing cloud computing, many of which are external to the actual contract you have with the company. Very important to think about these things, especially if you're either running a consumer service or planning on doing anything illegal. The platform as a service vendors can do more to secure web apps. As of right now, you do not, if you do bit for bit a copy of a web application into the equivalent platform as a service, you will possibly lose some of your security protections. So it's important to look at the application running in the real context as it is hosted. There are some unpredictable issues coming out of infrastructure as a service. Like Andrew said, it's kind of equivalent to the issue that Gutterman et al. Originally pointed out, which was embedded Linux devices like diskless OpenWRT machines. Pseudo-Random number generation is a black art, and Linux does not generally do a very good job. When you look and compare it to like Windows, where they have 28, 29 different entropy sources, it is a much more predictable set of things, and is not well suited for headless machines where the IRQ interrupts and disk IOs are simulated and happen exactly the same way every single time you boot. And so it does lead to unpredictable situations, and there will probably be some more of these bugs coming out because of the block-by-block copying of public template systems. We've talked to Amazon. They accept it as an issue and are looking at ways to fix it, but it's mostly a virtualization issue and something that should be addressed by the virtualization vendors through the creation of a virtualized hardware random number generator in the hypervisor. So the bottom line is that the state of security on cloud computing is kind of like security on the web in 1999, right? You could ask a security expert, is my web application secure in 1999? And they'd say, yes, it doesn't have any of the 3 possible vulnerabilities that anybody's ever had on the web, right? Because we're still at that point lacking 7 or 8 years of basic research into the fundamental flaws in those technologies. That's where we are with cloud computing. If you are asked either by your boss or a client, am I secure in using these cloud computing technologies? The answer right now, the smart answer is I don't know, but there are things you can do to try to mitigate some of these issues and make them a little more safe. So thanks for coming. If you want the slides, we have an autoresponder at blackhat@isecpartners.com. They'll send them to you. And we're out of time, so we'll take questions on the floor so the other folks can get set up. Thank you.